Hi, hello, and welcome to Ganitam Pathshala. Since this is the first episode of our channel, let me start with some introductions. I am Rahul, an undergraduate science student at ISER Bhopal, and this channel is all about gaining an intuitive understanding of some basic math concepts through some unorthodox explanations. So let's get started. The motto of this channel is demystifying math. So we shall try to look what goes beneath some of these math expressions, what is the underlying principle, what goes behind this stuff, and also try to answer the question that why do these things happen the way they do. So the first series of this channel is about demystifying math equations. So my college professor Ashok Sir used to say that if we look at a math equation with love, if we look at it caringly, then the equation will tell us that what it is trying to do. So we'll exactly do that. We look at the equation carefully and try to understand what it is trying to tell us. So let's get started with the first video. What's the topic for today? Let's see. Any guesses? What do you expect? It is exactly what you expected. It's the expectation value. This is not the expectation that our parents have on us every day. This is instead the math concept of expectation value in probability. So what does it mean? Let's see. So during my classes, sir had asked, what does expectation value mean? So one guy said, sir, expectation value is the value that we expect. Now what does that mean? You're just doing what Akshay Kumar does. That is this. That does not make any sense by just reversing the words. So let's see. Also, due to the competitive nature of today, competitive exams nature, before we recollect what does the concept mean, we recollect the formula. Yeah. Expectation value na summation x f of x. Yo, but what does the summation x f of x mean? From where does all these terms come in the equation? We need to understand that carefully. So, like every movie, when we shoot a movie, for every scene, there's a setting to the scene. Similarly, for every math concept, before we learn, there's a setting to it. So, what's the setting here? We have a random variable x, which takes certain values xi, and each of these values it takes with some probability. So the a random variable, suppose example we take a dice, we roll a dice, so it takes the value 1, 2, 3, 4, 5, and 6 with the probabilities of each 1 by 6. So just as a note, before I proceed in the video, I assume that you just have basic knowledge what's the definition of a random variable and probability. So this is the setting here for this random variable x, and to understand what do these expressions mean, from where do we obtain these expressions for expectation value, we shall take the help of a very special guest today. We have with us, let's see who do we have. We have with us Mr. Cool Toads. So Mr. Cool Toads is not any monster from your monster group in group theory. He is a friendly neighborhood number cruncher who will simply just help us make some calculations and make our work easier. But the catch is, Mr. Cool Toads does not understand our normal language, Hindi, English, Tamil, Bhasha. It only understands coding language. So in order to do that, let's head over to the coding desk and see what awaits. Come on, let's go. Yeah. So welcome to Mr. Cool Toad's desk. Yeah. Up here, I'm up here. Don't look down there. So welcome to Mr. Cool Toad's desk. Mr. Cool Toads has a simple task to do. He has been given three balls numbered 1, 2, and 3 in a box, and he has to just pick at random a ball from the box. But the speciality is that each ball has a different probability. Ball 1 has probability of just zero point 0.1, for ball 2 it's zero point 0.3, and for ball 3 it's zero point 0.6. So when you pick a ball at random, you have 10% chance of obtaining ball 1, 30% for ball 2 and 60% for ball 3. So I have a question for all of you. Just pause the video for a minute and think that when you pick a ball at random, which ball do you expect to obtain maximum number of times? What would be your safe guess? Of course, it would be ball number 3. It was a simple question since it has the maximum number of probability. So what are we doing here is Mr. Cooltorch will pick out a ball and note down the number. But since he has a high computing power, we shall do this 100 times and let's look at the results. So mainly in this video, I don't want to focus on the code that is being used here, but instead on what am I saying and what do we understand. So let's look at our results. So naturally we obtained maximum number of threes, after that twos and least number of ones, which can also be seen from this next line which says we have 8 ones, 33 twos and 59 threes. So I want to do a simple task. I want to add all these 100 numbers that I obtained, but it is stupid to add 3 plus 3 plus 3 plus 3 entire. But Mr. Cooltoes is smart. So he'll simply do, since we know that we have 8 ones, so we'll do 8 into 1 plus 33 into 2 plus 59 into 3. And that simply gives us 251. And now I want to find the average of this sample. So that's simply 251 divided by my sample size of 100 and that gives us 2.51. Now I want to repeat the same task, but instead of performing it 100 times, I want to do it 10,000 times. Because once we do that, we'll see the pattern which we are going towards. So when we do this 10,000 times, let's look at our results. We obtain 983 ones, 3055 twos and 5962 threes. Now I want to add it in the same way and obtain average, but with a little twist this time. Yeah. I'm back down here. So this time instead of adding the three terms and then dividing by a number of total number of observations of 10,000, I'm going to distribute the 10,000 into all the three terms. So let's see what do I mean. So 983 into 1 plus 3055 into 2 plus 5962 into 3 divided by 10,000. I'm going to break it down this way. Just distribute 10,000 into the three terms. So what do we obtain from this? 983 upon 10,000 approximately 0.1, 3055 upon 10,000 approximately 0.3 and 5962 upon 10,000 approximately 0.6. So what do we see? 0.1 into 1 plus 0.3 into 2 plus 0.6 into 3. Does this look familiar? Absolutely it does. This is the exact same way in which we calculate our expectation value given a random variable, that is summation x f of x. So this tells us why would one write this expression x f of x and where does it come from? Expectation value is simply the average of a large sample, or we can say that when we consider a large sample, the ratio of the number of terms of a particular quantity, suppose here 1, so 983 upon 10,000, this ratio tends towards its probability of occurring. So that explains us what expectation value actually is. That given a distribution, in this particular example saying that 10% of my entries are 1, 30% are 2 and 60% are 3, then what value do I expect to obtain on average? That is exactly the expectation value. So in this video, we understood that why would one write the average of a given random variable with probabilities? Why would one write the average value we obtain as summation x f of x? How do we obtain to this formula? We learned this through an example, through a computational example, that how do we arrive at this formula. But before we end, I would like to give you some gambling tips. But it's always over 18 and please play responsibly. So, if your friend tells you, come on, let's play a game, and if you get some number X, then you would win some rupees. And if you don't get it, then you would have to pay some amount of rupees. Then in that, there are so always calculate the expectation value in your mind, and if it is positive, then you can keep playing, because you know that if you keep playing, eventually you will end up on the positive side. If your expectation value is positive, eventually the average amount you earn will be positive and you will win. But if you know that the expectation value is negative, then you should not keep playing, because you know eventually you are going to end up on the losing side. If your expectation value is negative, you know you are eventually going to have a loss. So if you win once or twice in the beginning, just get out, just take the money and get out. So those are the few gambling tips for you special. So yes, that's it for today. Before ending the video, I would like to say, since this was the first video, I would like to know your comments. What are your views about this video? If you liked it, then drop a like and let me know what aspects you found interesting. If you didn't, if you are not able to take away something from it, then you can feel free to drop a dislike too and mention in the comments that where can I improve, what parts should I improve on, what more do you want to see in the videos, and also let me know what other topics would you like me to explain. So before I depart, I would like to end with a small quote. You can call it even advice, just a small quote which I have written. It goes as, do not worry about others' expectations. Do not worry about their mean comments. Do not think you are just an average student. Just make sure that the probability of you giving your best every day is always equal to 1. Thank you.